So, so what is a stream database? Right, that's the question that we're talking about, right?
Yes, that's a question.
Right,
What is a database?
right. Well, I mean, so that's where you start, right? So what is a stream database? And I think we're going to talk about, well, what is a database and why is a relational database relational? Why is a document database, and why isn't it an event database, right?
Yeah.
So I think those are all the questions we gotta address. So let's start talking first about the basics. Really simple. Why is a document database a document database, right? Because the addressable element is the document, right? What you can read from and what you can write to are the documents, right? That's really all there is to it. Key value store, right? You have a key, you write a value. That's what your addressable element is. We think about it as a data science problem, right? This is really just data structures writ really, really big, right? Um, so the question is, because once you have enough data to be in a database, once I've got terabytes of data on disk, I can't keep it all in memory. I can't access things quickly. So the database is fundamentally about a storage paradigm and an indexing structure to access it. And then you put all these standard things on top of it. But at its heart, it's like, what's your indexing approach? What's your storage structure? In a document database, they're saying the document is the core storage structure. We have a bag of properties on a document that you decide how you want to organize. A relational database is a little bit weird because it's been around so long, people have forgotten what the actual meanings are, right? So a relation is a row, really. A relation is all of the columns in a row form a relation. And a relational database happens to group their relations into tables. And they happen to let you have a query language to do set operations on tables and on join tables of relations. But the fundamental thing that you read, the fundamental thing that you write is the row.
Yep.
When I do a query, I get a set of rows back or a set of relations back. They don't even have to be the relations that were in the tables. I can say, here are the columns I want, but it's coming back as a set of these relations. Like all this data is related to each other. So that's what a relational database is, a document database, a key value store, right? So a stream database, why would we call event store, for example, a stream database? Is because what you write to is a stream. What you read is a stream. Now, in those streams are events, but you can't write an event to the store, right? So that's why it's not an event database. If we just had one all stream with everything in it, and you just wrote events to it in order, that would be an event database, kind of like Kafka, if Kafka didn't throw all the data away eventually, right? Because you just append things. But a stream database says, no, what we're saying is that we think, like a relational database, it's far more important to not just have an ordered ledger or ordered set of events. Those events actually form logical streams. And that's what we're going to address. And by address, I mean like you can write to a stream, you can read from a stream. So in a stream database, when I append to a stream, the event is put in the next position for that stream, right? And generally, when you're doing that, you're talking not about, I want a dozen streams, right? The same way you wouldn't if you had a relational database that had a dozen rows or you'd have 10 tables. You'd be like, that's not stock database. So we're talking about millions of streams, millions of addressable positions that you can increment events on, right? It isn't we have one giant log and they're all together. It's I can have a stream for every user, every entity, every process manager, right? Every single one of them gets their own addressable stream. And they're also on that master log. So they have both global ordering and a local ordering for the individual streams. And that's the heart of a stream database, is that decision to say, for any log in the database, we will support a global ordering on the log, and we will give you, as many individual append positions as you want, and you can read from any set or group of sets of those streams. And then on top of that, we're going to build the other things. We've got a lot of them, but queries and projected streams and materialized views and all those things, right? If you look at the way the projection engine works, it's kind of like stored procedures, but the core of why is it a stream database is events go on streams. You read streams, you write to streams, and the events are, in effect, our version of relations or our version of documents.
Yep.
An event is a mini document, or it's a mini set of related properties that you're writing at one time. So this write will contain a structure, which is a set of related, and that gives you this really atomic element, right? That I think is actually more fundamental than a lot of the writes and a lot of the representations in other stores. Because we never throw away that raw fundamental data.
Yep.
And that provides you tremendous capabilities for downstream systems, for AI and data warehouses and other stores, and building whatever you want. You can go from a rich event model into a relational model or a graph model or a document model very easily. But they're all kind of lossy. They lose this atomic data element. The other thing that's really important when you start looking at the modeling, we're getting a little bit off topic maybe, is that whereas in a relational store, all of the relations that get grouped into a table must be the same. Here in a stream store, we're saying that you can have a set of schemas. You have different events in a stream, and that's fine. And that gives us a second order of grouping, what we call a category. So we say all of these streams have the same set of schemas, and they're really a category. So I have a category type like user, invoice, account, thing, and then I'll have instance streams underneath it. And then that gives me both the low-level stream of the individual instance and a category stream, which is the ordering of all those events across that category. And so now we get a hierarchy of streams built up that we can now address. And that very top level hierarchy is the root, and that's effectively your all stream or the global ordering for this whole log from that root. So that's the primary division, is we say that we have a log, but that's not good enough. We want millions of individual addressable streams, each effectively with their own index, their own sequential incrementer, and that's where the indexing gets hard. And that's really the hard difference between doing this on top of another store. And then this hierarchy of streams where I can get the ordering for telling you about all users, right? And then we can also do virtual streams, or index streams, kind of like views, where we create streams of, say, like an event type. And in log order, we can give you all of the events in this sort of cross-cutting stream that cuts across the major divisions into these streams.
Yeah. Yeah. but if I'm going to take an example from event store itself, we have like the correlation ID that we can follow as well. That's also a kind of
That's a secondary
view,
stream or a virtual stream or a view.
a view. Let's say
Yeah.
a view, just like I would have in relational database.
Right. And that's why you have link tos. So if you materialize that view into a stream, you do that with a series of link to events that say, hey, here's the event I'm referencing. So effectively they're pointers.
Yep. So the hard work is in the indexing of all that when we're talking about high load.
Right.
Or
writing a million events into a million individual streams, where each one of those streams is going to both check that so we offer part of this incrementing idea is not just that it'll automatically give you the next number, but it means it will automatically, we will allow optimistic concurrency. So I want to write event 7. So I know when I was at 6, I want to write 7. It'll check to make sure that the next event is event 7. And that's the reason that's super useful is if I have a pool of different objects that are all working on this, how do I deal with if I have a conflict between this one writing and that one writing, right? If I want to, I can use the database to force, like only one of them will win. The first one writes, the second one will try to write 7 and go, oh no, you can't. You can write 8, but you can't write 7. 7 is gone. And I do that across millions of individual microservices. Yep. Or really, it's going to be microservices running different instances of individual streams.
Yep. And that's why you need a purpose-built indexing system, actually.
Yes. Yeah. If you don't index this way and you don't figure out how to make that work, it's a hard thing to do. Now, it's a really fascinating thing when you start looking at building these indexes, because all of the traditional literature on database indexing, and there's a lot of it, there's a really good, focuses on, optimizing for insert, update, delete, right? And this is an append-only model. We do allow truncation at the back end of a stream, right? So we allow truncation, but we don't allow data modification, right? And we don't allow deletes in the middle. So the parameters to optimize the indexing structures around are very different. And it's really kind of it's a really interesting data science problem on how do you align this traditional body of work and then restate it saying, okay, well, that's true, but I don't need to worry about this and that. And so you see in all these papers, they set up, oh, we assume this and this. I'm like, okay, I got to kill that one and that one. And now what does it mean?
Yeah. But I guess all this literature and all the research around the indexing and algorithm around that are basically mean because we have like, I don't know how long relational database exists, 40 years, 50 years. Yeah. There was a need because that was the primary storage. Now, I hope that in 40 years we'll have a lot of literature about indexing for event streams database.
Yeah, 100%. And what we're doing now is we're actually reading those and building things with it.
Yep.
And things that we know work. Things we're testing now to say, okay, we've got 1 billion events, 7 terabytes of data, and a quarter of a billion streams. Go.
Yep.
All right. Yeah. Doesn't work.
Yeah.
And then how do you shard that out and how do you make that all work? So so that's the crux of it is the stream database, because you write streams and you read streams, and those streams have events. And if all you had was the log, then sure, it could be an event database. If you provided event database get levels of guarantees.
Yep.
Right. But and I think the stream database also allows you, it's a richer model, and from that core model, you could decide you want to write everything to one stream. That's perfectly valid. and you could create a ledger with it, right? So all of these other things are possible from this root, but we find that this root abstraction of it's not an undifferentiated log, that it's a log that has logical streams, and those streams have a hierarchy, and those are the addressable elements, and those are the basis of concurrency, and the basis of both reads and writes provide the most useful model for dealing with event data.
Yep. So we have a new category of databases.
Yep. Well, I would say it's a really old category. We have a new name. We've recognized a very old category of database. You know, an event store has been a stream database for a decade, right? But it wasn't born anew, right? Mm-hmm. Event store was an implementation of a well understood model at the time, right? So what we're really doing now is we're just bringing forward this model that's been around for at least 15 years. But if you go back and you look at the old research before relational databases took off, you'll see these models being built in even older systems. You know, not called out necessarily this way, not defined as formally and as rigorously, and definitely not the scale that we're doing it now. But that's what it is. And you know, and where we're looking to go forward with event store is to have clusters with multiple logs and that horizontal scalability in each log implementing a full stream database in it, and those logs being grouped together into a cluster.
Which brings its own set of problems, which might be an interesting thing to talk about next time.
Well, you know what the number one cause of problems in the world is, right?
No.
Solutions.
Solutions, okay.
I fixed this, oh, that breaks that.
Yeah.
That's the history of technology for the last several thousand years.
Yeah. So, in short, a stream database is exactly what the name implies. We have streams, we append event to them, and we have good indexing technology above that.
You write to streams, you read from streams. What you write and what you read are events, but the stream is the primary abstraction. It's the primary addressable element in the database. You know, and from there you can build on a pure event log if you want, just have one stream. You can build a ledger if you want, you know, again, have one or more streams. So, you know, and from that core model, you can also build every other data model you want. It's the only really lossless data model that I know of that's available. Everything else, maybe a historical key value store, but there, what you're addressing is the key, and you're not really getting the same guarantees that you get.
Cool. Thanks.
All right.
Yeah. Thank you. Bye.